All right, this is the last day of Unit 6 where we're going to talk about expected value in games, and we're going to start off looking at how horse racing and bets and odds and stuff like that are calculated and how you can figure out how much money you bet based off of how much money you win. So this is how it works. We're going to pretend that we have 4 different horses, and these are the odds right here, odds in horse racing. So horse 1 has 4-to-1 odds, horse 2 9-to-2 odds, horse 3 2-to-5, horse 4 1-to-3. So what does that mean exactly? Well, let's just take horse 2 for instance. And if it has 9-to-2 odds, that means for every $2 you spend, you profit $9. Okay? For every money you spend, you profit that amount. So if you spent $2 and bet on horse 2 and he won, you would profit $9. But you would take home 11 because you would be taking home what you spent too. So you get your money back plus your profit. So, if horse 2 won and you bet $4, so horse 2 wins and you bet $4, where $2 was the minimum, so you bet double the amount of the minimum. So if you bet double the amount of the minimum, like so, in other words, that says 4, then this would be 18, and you would profit $18 and take home 22. You would get your $4 back that you spent. You can also think about it this way. We can add 9 plus 2, our ratio together, to get 11. And then we can multiply by how much more we're multiplying by. If we multiply by the minimum, we would just keep that as 2. We wouldn't multiply that by that. But we're doubling the amount of the minimum. So if we double that amount, we get 22, which is the same thing. That's our take home. Okay, let's look at this example real quick where we have horse 2, and you bet $100, how much will you win? Well, horse 2 had odds of 9-to-2. So we can do this a couple ways. If I bet $100, that's 50 times more than the minimum, right? And the way you kind of think about that is like 2 times what gives me 100? Well, 2 times 50 does. And if I do that to both sides, this side becomes 450 to 100. And this tells me that I profit $450, and I take home a total of $550 because I add those together for my total amount that I take home. Once again, you can think about this another way. We can take 9-to-2 odds. We can add those together to say that's 11, and then think about how much more you bet. Like how many more times you bet. Don't multiply by 100. You need to multiply it by, it's 50 times more than the minimum. So we multiply that by 50, and we get $550. Okay, before we do, well, yeah, we'll come back to that one. So if you bet $24 on horse 4 and he wins, what is your payout? So horse 4 had a 1-to-3 odds. Let's see what that looks like. So you bet you bet $24. Well, $24 is 4 times as many as the minimum bet of 3. So I bet 4 times as many. So I'm going to do that to both of these, and that's going to give me 4 over here. Oh, sorry, that's not 4 times. It's 8 times. My bad. Times 8. And that's going to give me how much I paid and how much I won. So I profited $8, but I only took home $32 because most of what I spent was money that I spent. So I didn't actually, this actually is not a very good horse to be betting on with 1-to-3 odds. Anyways, we can also think about it like this. If I add those together, that gives me 4, and then multiply that by how much more I betted. So that would be, I bet 8 times more than the minimum. That would give me $32. So both of those work out the same way. Let's look at this example that I did not have on my PowerPoint, but it's in your notes. If you bet $500 on horse 1 and he wins, what is your payout? So horse 1 had a ratio or an odds, of 4-to-1. And that says for every dollar you spend, you profit $4. In other words, if you bet $1, you would take home 5. Because you bet $1, you profit 4, and you get your money back. So if I bet $500, that's $500 more than the minimum. So if I bet $500, I end up taking home $2,500. I profit $2,000. And I get my $500 I spent back. So this would be what I would take home. You could also think about it this way. Once again, 4-to-1. We can add those together and get 5. How much more did we times more did we start our bet at than what the minimum was? Well, it was 500 more because it was a dollar bet, and we did 500 of those, and we get $2,500. So that's another way we can think about that. Okay, odds in roulette. So let's talk about a little bit about roulette. Roulette is a game that's played in casinos. It consists of the following, so you probably need to write this down because I didn't have this in my PowerPoint. So it's a wheel that looks like this, and there's in that wheel, it kind of varies depending on what roulette you're talking about, but we're going to look at where this wheel has 38 different slots in them. And you take this ball, and the ball rolls around this wheel, and it's going to land in one of those slots. Now, the slot is consisting of 18 red slots and 18 black slots. And you may think, well, that's not 36 slots. And you're right, because there's 2 green slots. And they're made up from numbers between, I guess, 1 and 36. And except these green ones, you'll see them as 0 and 00. So this is kind of some information about roulette. So let's look at some examples. If a roulette wheel has 38 numbers, 18 are red, 18 are black, and I did have this on there, and 2 that are uncolored, or they're green actually, 0 and 00. So suppose you make a dollar bet in roulette. What is your expected value for a bet on red? So what is your expected value for a bet on red? Well, let's think about this real quick. The probability of us landing on a red would be, well, how many red spaces are there? There's going to be 18 red spaces. Out of how many possible slots do we have? Well, we have a total of 38 slots. So that's the probability of us landing on red. So to find the expected value, we need to take into consideration the probability times the event, how much I'm spending on that, or the outcome, sorry. So if I have 18 out of 38 that are red, and if I land on one of those, I get $1. So I'm going to multiply this by however much I put down, $1. Well, then I also have how many that are not red. So if I have 18 that are red, then I'm going to have 20 that are not red. 18 of them will be black, and 2 of them will be green. And for any one of those that I don't hit, I'm going to lose that $1. And I get something that looks like this. So if I bet on red, this is how I would set that up. Our probability of this event times the outcome. And then this would just simplify to negative 0.0526. Which is about a nickel, 0.05 cents. So this basically means that on average, over time, you would lose a nickel every time you spun the wheel and bet it on one of those colors. Okay, so let's see what happens when you bet on just a single number. We can say 17. Well, if there's 38 slots, there's only one number 17, and I'm betting $1 on that. So for every there's only one 17, which means that there are 37 numbers that are not 17. And if I bet $1 and I don't hit it, then I'm going to lose that $1 that I just bet. And I get something like this. And then from here, I can do those calculations and I get the following. I get negative 0.947 blah, blah, blah. And so that's roughly negative 0.95 cents. So I end up losing basically almost $1 every time I bet on one number. That's the expected value for me to get. So online casinos. One side, so we're going to talk about what's fair and what's unfair. So when you ask if this betting game is fair or unfair, fair is when you have an expected payoff expected amount to be 0, and unfair is when you have a loss of 5.26 cents or more. Okay, so let's look at an example and see if we can determine if it's fair or unfair. So in order to raise money for the Golden Agers Club is conducting a charity lottery. The first prize is announced to be $10,000 with 20 extra prizes of $500. Tickets are available for purchase at $10 a piece. Assume that 10,000 tickets were sold and that no additional tickets will be available. So if you bought a $10 ticket, how much money would you expect to lose? Okay, so let's think about this real quick. Where I'm going to make a table here, and in this table there were 10,000 people, because we said assume that 10,000 people bought a ticket. 10,000 out of 10,000 people bought a ticket for $10. So we end up getting, they spent $10. So this would just simplify to 1. Okay, so for every one person, they spent $10. I lost $10. Then we also have another scenario where out of those 10,000 people, 1 out of those 10,000 people is going to get $10,000. So that's one of our circumstances, right? It says first prize is announced to be $10,000 with 20 additional prizes. So that means that 20 additional people can get prizes, so 20 out of 10,000 can get $500. So we end up getting something like this that we're going to use, and now we can set this up as an expected value. So my expected value would be negative 10 times the probability of that, which would be 1, plus 10,000 times the probability of winning that. 1 out of 10,000 will get that, plus 500 times the probability of being one of those. So 20 out of 10,000 will get $500. So what's my expected value? Well, my expected value when I do this, when I calculate this all out, is negative 8. And what that means is that when I donate, I'm losing negative 8 for every ticket sold. I'm donating negative 8. Or sorry, I'm donating $8. Is the expected value. So if you bought 10 tickets, how much money would you expect to be donating to the charity? If I bought 10 tickets, then that would just be 10 times my expected value, which would be negative 80, which is $80 donation. Donating $80. Okay, let's look at another type of example. Consider a game in which 2 coins are tossed. The payoff are as follows. Both heads, you win $4. Both tails, you win $3. And one of each, you lose $5. Okay, so we have, let's list our scenarios. We can have 2 heads. We can have a heads and a tails. We can have a tails and a heads. Or we can have a tails and a tails. So, okay, so for us to get a heads at so if I land on heads out of heads, that's 1 out of 4 possibilities that I have. But if I land on heads, I also get heads and heads. I also get $4. If I land on both tails, that's also 1 out of 4 type of scenarios I can run into. But if I land on that, I get $3. And then if I land on any of the other outcomes, that would be 2 out of the 4 possibilities. Then I lose $5. So I'm just going to keep that like this. If I add these all together, that should give me my expected value, which would come to negative 0.75, which means that I could expect on average to lose 75 cents every time I play the game. So is this a fair game? Sorry. Is this a fair game? No, because a fair game, the expected payoff would be 0. Expected payoff is not 0. Okay, and that is this unit. So have fun. It's time to complete worksheet 6.7 and then get ready to finish this unit. Have fun.